Hello viewers, in today's session we are going to discuss another important problem from limits, right? And in this problem we are going to discuss this limit in which we have to find the left hand limit of this function involving the mod function and the greatest integer function, right? So here we have to evaluate limit x tends to a minus. Here the negative sign shows that we have to find the left hand limit of this function when x approaches to a from the left of x is equal to a, right? And the function is the mod of x raised to 5 divided by a minus greatest integer of x over 2a raised to 6. And the important thing is that here this quantity a is greater than 0, right? So it means a is a positive quantity. So let us see how we can simply evaluate this limit by using the concept of greatest integer function and mod function, right? So let us start. So now see here we can call this limit as L, right? And here we have two terms. The first one containing the mod function and the second one containing the greatest integer function, right? So let us first take care of this term, right? Now see here we are given a is greater than 0 and x is approaching towards a from the left of a, right? So it implies that if we have x is equal to a here, then we are approaching towards x is equal to a from this side, right? So when we approach towards x is equal to a, we reach at a point which is called the left neighborhood of x is equal to a, and this point is a minus h, right? Okay, now see a is greater than 0. So we have this important inequality, that is x is greater than 0 and less than a, right? So we'll start from this inequality. So x is greater than 0 and less than a because we are approaching towards x is equal to a from the left of x is equal to a, and all the values of x which we are taking into consideration are less than x is equal to a, right? And a is obviously greater than 0, we are already given, right? So x is greater than 0, less than a. So let us divide throughout by 2a, right? Because here we have x over 2a. So dividing throughout by 2a, we have 0 over 2a. Then we have x over 2a. Here we have a over 2a, right? And obviously a is greater than 0. So a is not equal to 0. So now here we have 0, here we have x over 2a, and here we have a and a get cancelled. We are left with only half, right? So now this inequality suggests that this quantity x over 2a, it lies between 0 and half, that is 0.5. Right? So by the definition of greatest integer function, if any number lies between 0 and 0.5, then the greatest integer less than or equal to this number is that is equal to 0, right? So the greatest integer of x over 2a is equal to 0, right? Because it lies between 0 and 0.5. So now this quantity is 0. So we can now write limit x tends to a, negative sign, and then we have mod of x raised to 5 over a, and this quantity is equal to 0 because greatest integer of x over 2a is 0. So here we have 0, right? So now we are left with limit x tends to a minus mod of x raised to 5 over a, right? Now we can take x is equal to a minus h. So when x tends to a, then h tends to 0. And here h is infinitesimally very small, and h is a positive quantity which is greater than 0 but less than 1. So here we have limit h tends to 0, and then we have mod of x x can be replaced by a minus h raised to 5 over a. So now we have a limit h tends to 0, mod of a minus h raised to 5. So we can take h is equal to 0 here. So now we have a mod of a minus 0 raised to 5 over a. This is mod of a raised to 5 over a, and a is positive. So we can now write simply a raised to 5 over a. So this get cancelled. So we are left with a raised to 4. So where's the value of this limit is equal to a raised to 4. So this is how, by applying the concept of greatest integer function and mod function, we can evaluate these kind of limits.